All right, I've submitted your test. If you haven't, then I highly suggest you go do that before you start watching this video. But we are going to start our final unit of Algebra 1, a little bit abbreviated than what we would normally do, but we still need to make sure we cover this stuff so you're prepared for Algebra 2 next year. So, square roots. Some of you have probably seen some of this stuff. Some of you have learned different ways of doing it. So if you already have a great way for doing it, that's totally fine. I'll show you a couple different ways that we can work with simplifying square roots, but this is something you'll do the rest of high school in math. So make sure you get this down. Okay, so a couple quick definitions that are out there. A square root is the inverse operation of squaring, basically. So if I'm doing a squared equals b, then I can take the square root of each side, and a would have to be the square root of b, right? Those two things are inverse operations. Important things to remember about square roots. Every positive real number actually has two square roots. So like when I ask you about, what's the square root of 4, right? So if I'm thinking of what's the square root of 4, we would normally say that's 2. But technically, it could also be -2, right? 2 times 2 is 4. -2 times -2 is also 4. So it means by every positive real number has two square roots. The symbol, the square root of a like that, denotes the principal square root of a. The principal square root of a just means basically the positive version of that. And we'll talk about this a little bit more when we start doing examples. 0 is the only number that only has one square root because its square root is just 0. There's no positive or negative to 0. A couple of properties here that are fairly important that we will use quite a bit in the coming problems that we do in this unit. For any non-negative numbers, a and b, if I am multiplying them inside the square root, I can separate them into the product or the square root of their factors. So for instance, like if I had the square root of 12, I could rewrite that as the square root of 3 times the square root of 4, right? If you had the square root of 2x, you could write that as the square root of 2 times the square root of x, right? You can separate that product into its factors, or it works backwards, right? So I could go ahead and take, if I had the square root of 3 times the square root of 4, I know that that equals the square root of 12, right? Same thing with division. You can separate a quotient into its two things, or into a fraction. So if I had the square root of 10 over 15, I can separate that into the square root of 10 over the square root of 15. And same vice versa, if you had them separated, you can put them back together as a fraction. Okay, so let's just get into examples. We'll see how we use some of those properties and things as we go through these. Okay, so on these first few, we want you to get some practice, no calculator. So you won't use a calculator on most of these. I know you guys have them at home, but please try to know these without one. And some of the other ones we do later, we'll use a calculator for basic division if you need help, but we're trying to do the square root part without a calculator, okay? I always tell my students it's really beneficial if you just know your perfect squares all the way up to 20. If you can't get to 20, at least get to 15 or 12. Okay, but I think it's really great. And when I say that, I mean that you know that 1 times 1 is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, the next one's 25, 36, and so on. If you know all of those perfect squares all the way up to 20 squared, that is very, very helpful because you don't have to reach for your calculator every time. Okay, so this first one, if I want the square root of 100, hopefully we know that one. We know that that is 10. Now, in this case, this is that principal square root, right? It means I only want the positive square root of 100, so my answer is 10. Okay, the next one, again, I need the square root of 81, which is 9, but this time it's not the principal square root, it's the negative square root of 81. So that means I just put a negative in front of my answer, so -9. The next one, I want the square root of something squared, right? Well, if I think about this, that just means the square root of 12 squared, which is 144, and then the square root of 144 is 12. But you can skip that step. Anytime you see the square root of something squared, Those two things are inverse operations. They cancel each other out, so your answer is just 12. Okay, so you don't have to go through all of that extra step, but you can if you need to. Same thing on the next one. This is a square root being squared. Those two things are inverse operations of each other, so you should just know that the answer is 5. If you got to think about it, that means the square root of 25, which is 5, right? But we want you to be able to just go straight to the answer. Okay, this next one's got this lovely sign. Some of you may have seen, or some of you may have not. That is a plus or minus sign. So this actually means I want both square roots of 9. So I don't want to say it's just 3. That would be plus or minus 3. And again, that just means 3, and it also means -3. I want both of those options. Okay. Okay, if I want to subtract the square root of 25 minus the square root of 16, do not just subtract those two numbers here. Order of operations, anything inside of a square root is like something being in parentheses. So I do the square roots first. So the square root of 25 is 5. The square root of 16 is 4. Then I can do my subtraction, 5 minus 4, and my answer is 1. Okay. Now this next one, the 25 minus 16 is actually inside the square root altogether. So I am going to do that subtraction first. 25 minus 16 is 9. It's still inside the square root. And now the square root of 9 is 3. Notice, by the way, 2 different answers here, right? All because of order of operations. So be careful about that. And that'll come up again later. Okay, the next two. So here we've got a couple bigger numbers where maybe it's a perfect square, maybe it's not. I always tell students, like, this is where it's handy to have your calculator on hand. Make sure you know where your square root button is. But it is helpful to decide before you start doing anything else. Figure out if these are perfect squares. If you don't have a calculator, one other way to do this is to think about another square root or another perfect square that divides into this number. So with 225, it ends in 25, so it's like $2.25, right? So this divides by 25. I could separate it up into quarters. So if I divide that by 25, I could rewrite 225 as the square root of 25 times the square root of 9, because 25 times 9 is 225. And now those two square roots are ones that I know. The square root of 25 is 5. The square root of 9 is 3. And then if I do 5 times 3, I get 15, which means the square root of 225 is 15. Ta-da! Okay. Same thing on our next one. Break it up into smaller perfect squares if you can. So 2304, that's probably divisible by 4 because it ends in 04. I might try to think of a bigger square root just in case. I can check my divisibility by 9. 2 plus 3 is 5. 5 plus 4 is 9. So then that number is actually divisible by 9. So if I do 2304 divided by 9, I get, and there's where you could use your calculator. I get 256. And now you could keep going with the 256 if you need to do more. I know that 256 is a perfect square because I know my perfect square is all the way up to 20. So then I could think the square root of 9 is 3. The square root of 256 is 16. And then 3 times 16 is 48. So the square root of 2304 is 48. Now again, if you needed to break down 256 a little bit further, I could have done square root of 9. 256 is divisible by 4, right? And then 256 divided by 4 is a 64. So those are smaller perfect squares, but again, I would get 3 times 2 times 8. 3 times 2 is 6. 6 times 8 would still give us 48, right? So if you need to break it down further, you can. But that's one way you can find out if something is a perfect square. If you didn't have your calculator, if you have your calculator, just type the number in first, see if it's perfect square. Okay, the next one, this is using some of our other properties we saw with the division. So I've got the square root of 36 over 121. I can't simplify that fraction, but I'm doing the square root. So remember, you can split this up. I can rewrite this as the square root of 36 over the square root of 121. Oh, I gotta make that whole thing negative, right? So then on the top, I would get 6. On the bottom, the square of 121 is 11. And then I just got negative 6/11. Okay, so look at whether the top and bottom are perfect squares. All right, our next one, we've got 12 over 75 inside a square root. Now again, we can split those up, but neither of these are perfect squares. 12 and 75, those are not perfect squares, so that may not help us very much right now to split those up. What else I notice is that 12 over 75, I can reduce that fraction. Those are both divisible by 3, right? So I'm going to divide top and bottom both by 3. Keep it inside the square root because we haven't done that yet. 12 divided by 3, that's 4. And 75 divided by 3 is 20. If I look at my fraction, those are both perfect squares. So I can split it up into the square root of 4 over the square root of 25, which would give me an answer. Now I can do my square root of 2/5. Ta-da! Okay. All right, and then the last one, a decimal. Again, you can kind of think of it as a number, or I think it's easier here if we make this into a fraction, because then I can use the previous methods we were talking about. So this is 12 and 1/4, right? And then I'm going to make that into an improper fraction. That would be 49 over 4. And then I notice, hey, those are both perfect squares. So I can break that up into 49 over 4, which would give us an answer of plus or minus 7/2. Okay, so decimals, sometimes you can change those into a fraction, which will make it easier. Okay, so those are all so far. These have all been rational square roots. What we have done has simplified to an integer or a rational number. So these have all been rational square roots, meaning when I take the square root of it, I get an integer or a fraction, right? Now we're going to look at some irrational square roots. Irrational means that I'm not going to get it all the way out of the radical. There is going to be a part left over that I can't write as a fraction. It has to be a decimal or a repeating decimal. So if I put these in my calculators or in my calculator, I'm not going to get an integer or a fraction. I'm going to end up with a repeating or a non-repeating, non-ending decimal. That's what makes it irrational. However, just like we always simplify fractions, we are always, from here on out, going to simplify our square roots. And what it means to simplify a square root is we're going to factor out the perfect squares, is basically what this means. Okay, now there are a couple different ways to do this. And on this first one, at least, draw perfect squares. I will show you both ways to do it, and then you can kind of decide which way you like better. Okay. The first way I like to think about it is kind of how we were doing these problems up here, where you can take a number and you can break it down into its products, or I'm sorry, into its factors. Remember all the factoring stuff we've done, right? It's kind of the same thing. It's just only a number. It's a little bit easier. So I'm going to break 324 down into some of its factors. Now, the useful thing is here, I want to try to come up with a perfect square factor, because if I come up with a perfect square, I can actually get the perfect square of that number, or take the square root of that number and get an integer and get it out of the square root. So for 324, since this ends with a 2/4, this is divisible by 4, right? Okay, so I'm going to break this down into the square root of 4 times, and if I divide that into 4, the square root of, let's see, that would be 8, and then 1, right? And now on this one, we end up with, hey, look, they're both perfect squares. So then if I take the square root of each one, I get 2 times 9, which is 18. So 324 is actually a perfect square. Maybe I didn't plug it into my calculator and I broke it down that way, right? Now, the other way people like to do these is not by thinking of perfect squares that divide in, but just coming up with the prime factorization of the number. So the other way you can do this, switch colors here so you see it in another way, is I can start with my square root of 324, and I'm going to do a factor tree and come up with my perfect or my prime factorization. So 324, let's say I decide to divide it by 2, right? That would be 162. And then maybe I'll divide by 2 again. And that will give me 81. And then 81, I know, is a 9 and a 9. And then I get 3s and 3s, right? Okay, so then I'm going to look at that prime factorization, and I'm going to put it all underneath a radical here. So I've got, oops, sorry. Oh no, my battery. Okay, so I'm going to take this and write this out. So I have a 2 and a 2. That gives me a 2 squared. And then I have 4 3s. So 3 to the 4th, right? But then that's all inside a radical. Now here's where if I've got the square root of 2 squared, right? I know that that is just 2. And then because I'm doing the square root, it would actually be helpful if I always write these in squares. So actually, instead of 3 to the 4th, I'm going to do it as 3 squared times 3 squared. Then, because those are all being squared, if I take the square root of that, that just eliminates the squared, and I end up with 2 times 3 times 3, which is 2 times 3 is 6. 6 times 3 is 18. So same answer as I got in the top, just another way to think about it. If you don't want to have to come up with a perfect square factor, you can do the whole factorization. Okay? All right, we'll do the same 2 ways on this next one. Hopefully I can make it with my battery here. Okay. So 75, if you want to do it this first way, if I think about a perfect square that divides into that, I would try 25 here, right? 75 is divisible by 25, and that's a perfect square. So the square root of 25 times the square root of 3. And then, now this one's a little bit different because I've got this perfect square, right? The square root of 25 is 5. The 3 is not a perfect square. So this one is actually an irrational root. We have this piece left where I can't do anything with it. So it's going to stay inside the radical. So the simplified version of the square root of 75 is 5 times the square root of 3, or 5 radical 3. All right, we'll do this one other way with the factor tree, in case you want to see it that way. 75 and square root. I could break this down, divide by 5, and I get 15. And then 15, I get 5 times 3. So then my prime factorization would be 3 times 5 squared, all in the radical. The square root of 5 squared would just be 5, but then that 3, since it's still left inside the radical, it doesn't have a squared, so it's going to stay inside my radical, and I get that 5 root 3. Okay, all right, one more here. Notice this one, we've got a number outside the radical to start with. That's okay. We'll just multiply that on at the end. Okay, and this one, if you'd like to do the pink version, that's fine. This is one where I'd probably go straight to the factor tree because it's a bigger number and I think it's just a little bit easier. So I'm going to take my 112. I can divide that by 2 to start with if I want to, and I would get 56. 56 can be a 7 and 8, and the 8, see, we get 4 and 2, and 4 is 2 and 2. Okay, so I've got 1, 2, 3, 4 2s. I'm going to break those into pairs because I'm doing a square root. So 2 squared times 2 squared. And then I also have a 7 times 7, right? Then take the square root of the things being squared. I get a 2, and I get another 2. And then the 7 is by himself. It's not squared, so that has to stay inside the radical. So that gives me a 4 radical 7. Here's where I got to remember, though, don't forget about this 2 out in front, right? So that guy, if I keep him here and I keep him here, that means now he's still outside the radical. Got to do 2 times that whole thing, which will give me 8 times the square root of 7. Okay. All right, so there are how we simplify square roots. You have a homework today that we're actually going to do on paper because I want to see your work and make sure that you're able to either do coming up with the perfect squares or doing the factor tree. I will say that I find most students go to the factor tree, so you might try that way first. If you feel really comfortable with your perfect squares, you might do okay with the perfect square version. Okay, so get that homework done, and then when you're finished, you can submit that to OneNote for credit.